Team, it's Mr. Z, and today we're going to solve some rational equations. This is what we've been working for. Basically, everything this unit has been building up to this moment. Let's take a look. Okay, so when we're solving rational equations, the idea is that we want to first look for when the denominator breaks. Remember, any situation when it has a denominator of 0 is going to result in an asymptote, right? This has been what we've been discussing. So when you assess this, before you do any process, you need to go ahead and look for the domain restrictions. So let's look at each fraction in the equation and see what values will cause the denominator to be 0. Looking at this first one, I see that x cannot be 0 for both the first fraction and the second. 0 makes 0, and 0 squared is still 0. Now, after doing the domain restrictions, what we're going to do is we're going to multiply by the LCD. In this case, I see that the LCD is going to be x squared. Now, I can multiply by x, but by multiplying by x squared to both sides, it is going to eliminate the denominators. I always like to rewrite my fractions with an extra long denominator so I can fit what I'm multiplying it by. So I multiply the left side by x squared, multiply each term on the left side, and then the right side as well. Now, in order to show you what's going to happen, x squared over x, if I look at it in expanded form, that's the same thing as saying x times x over x, and I know that they're going to cancel, leaving 1x. So essentially, I'm going to rewrite this line, and it's going to be x plus, and then if you want to cancel the exponent, that's one way to visualize it. What's left? 1 equals 2x squared. Okay, so step one, essentially what we did was we eliminated the denominators. Now, it is an equation that is a quadratic, and this is what we were doing in the previous units. We have to use the zero product property in order to solve this equation. The zero product property, zero product property. So let's get it equal to 0. I'm going to go ahead and I'm going to subtract x and 1 from both sides. This is going to result in an equivalent equation where 0 is equal to 2x squared minus x minus 1. So I made it equal to 0. The product part comes from factoring. I need to rewrite it as a factor pair. So what I'm going to do is I put 2x squared here. I put negative 1. And the idea is I need to figure out a situation to get negative x. I look and see, well, 2 times 1 is going to be 2. And x times x is going to be x squared. I need my green region to be negative x. So I am going to strategically place the negative in a spot that is going to cause the green region to be negative 1. So I want my 2 to be multiplied by a negative. Negative 1 times positive 1 is negative 1. When I multiply this out, negative 2x and 1x come together to create negative 1x. That is what I wanted. So I know I've been able to successfully factor 0 is going to be equal to 2x plus 1 times x minus 1. I wrote it out as a product. The last part is the property, and it's essentially asking you, when do both of these numbers equal 0? Some of you are able to see immediately that the number that will cause this to be 0 is x equals 1, but some of you might be unsure over here. Remember, the property part is you have it, when does 2x plus 1 equals 0? When does x minus 1 equals 0? And using inverse operations, you can identify this exactly. Oh, x has to be 1, just as I knew. I go ahead and subtract 1 from above, and it gets 2x equals negative 1, and I divide both sides by 2, getting negative 1/2. So I figured out using the property that my solutions are x equals 1, x is equal to negative 1/2, and now I have to just check my domain restriction. I look up, what did I check before I started solving? That x can't be 0, none of my solutions are 0, so voila, I've been able to successfully solve a rational equation. Notice how my answer includes what x is, what x cannot be. Part of this is just eliminating the denominators so that we can just worry about the math. Let's go ahead and try this next problem. All right. Now, immediately, something goes off in my brain, my autopilot ticks, and I see that I want to factor out the middle term. I always put a parenthesis around the denominator when it has multiple parts. X squared plus 3x is going to factor out to be x times x plus 3 equals 1 over x. I'm going to go ahead and look at my domain restrictions. So this is my domain restrictions, dr. I'm going to abbreviate. In my first one, x cannot be negative 3. That would cause this first term to be a denominator 0. Next up, I'm going to go ahead and look at the second term. X, when does that make 0? Well, x can't be 0 there, nor can x be negative 3. And then from this last guy, if I just put 0 there, x can't be 0. It's important that you scan all of the denominators for any opportunity that will cause my equation to break. Okay, it's in factored form. Now what I'm going to do is I'm going to multiply all parts by the denominators. X plus 3, and I'm going to extend it, leave a gap, 6 times x plus 3 equals 1 over x. I'm going to multiply by x plus 3. I multiply all of my terms by it. You have to multiply the left side and the right side. Let's go ahead and cancel. Boom, boom. And it does not cancel here. So when I rewrite this, 2 plus 6, what's the survivor? X is equal to, well, 1 times x plus 3 is just x plus 3 over x. Notice how some of my denominators got canceled? That's what I want. I want to solve this equation, so I got to get rid of the denominators in order to convert it into a form that I know how to solve. I'm going to go ahead and multiply all of the terms by x now. I see my denominator has an x left, and then cancel, cancel. So remaining, I have 2x plus 6 equals x plus 3. Okay, time to solve this guy. So there are two techniques you can solve this. I'm going to go ahead and show you the way that I would prefer you to do it, and then I'm going to show you the alternative. All right, 2x plus 6 equals 0. I want to get one side equal to 0, so I'm going to subtract x and negative 3, x and negative 3. This is going to cause it to be, well, x plus 3 equals 0. What number plus 3 is 0? Oh, well, when x is negative 3, that will cause it to be 0. Some of you, however, might want to do it this way, where you have 2x plus 6 equals x plus 3. And I'm going to subtract x from both sides. I get x plus 6 equals 3. And I subtract 6 from both sides. And I get x is equal to negative 3. Both instances, I get the same answer. I would prefer this first technique because this is having you think of it as a form of a quadratic. What number causes it to be 0? But the latter is important as well. So my answer is, well, x is equal to negative 3. And then x cannot be negative 3, 0. Huh. Wait a second. I'm saying my answer is negative 3, but x can't be negative 3. So actually, there are no solutions because x cannot be negative 3 and 0. You have to check your domain restrictions with the solutions you get. This is the reason we do it in the beginning for this specific instance. I got a solution, but unfortunately, when I plug negative 3 in, it causes the denominator to be 0. Okay, let's do the final one. Immediately, your brain siren should go off. I need to factor this bad boy. X plus 2 plus, what is this going to be? Well, I factor the top. Just leave it be. You can factor the top, but for most of these, I would save the factoring of the numerator until the very end when you need to. So I'm going to actually ignore it. I know I can take a 2 out of it. I'm just going to resist the temptation and only factor the denominator. Now, I see that this 2x plus 2. Now, this denominator might be a little more complex to do mentally. If you can't do it, go ahead and write out your area model. I have 2x squared. I have 3. 2x times 1x makes 2x squared, and I need it to be 5. So I have to put the 3 there, the 1, 3x, and 2x. Does that make 5x? Absolutely. So this is how I factor this. Don't ever be afraid to draw out your area model. They will always help you factor some quadratics out. So this is going to be 2x3. What type of 3 is it? Positive 3. 1x1. 1x plus 1. Voila. Time to go ahead and identify my domain restrictions. When are the denominators going to be 0? In this first one, x cannot be negative 2. In this second guy, you might be like, oh, 2x plus 3, I don't know when that's going to be 0. Well, set it equal to an equation. When is this going to cause it to be 0? Using your inverse operations, you should see that x is going to be negative 3 halves or negative 1.5. Also, x cannot be -1. And then at the end, x cannot be -2 again. I scan all of my denominators. We'll clean up the repeats at the end. Okay. I'm going to go ahead and begin to chip away at some of these denominators. So writing it in factored form is only the beginning of the process. I see x plus 2, x plus 4x plus 6. I put it in a parenthesis, 2x plus 3. And then I'm going to drop that coefficient. 1x is the same as x plus 1. I'm going to put a parenthesis around x minus 1 and then rewrite it as factored form. I'm going to multiply this all by x plus 2. That's my first denominator. What cancels? Well, x plus 2, x plus 2, x plus 2. Oh, wait, no, nothing. I got to watch for that. Sometimes some terms will cancel, sometimes will not. In my last term, x plus 2 and x plus 2 cancel. So let's go ahead and rewrite this in order to have a new perspective. I have x plus 4x plus 6 all over 2x plus 3 times x plus 1 equals x minus 1 all over 2. And then I got to make sure I include the leftovers because x plus 2 did not cancel in that middle term. I'm going to multiply by another denominator. I'm going to multiply by 2x plus 3, 2x plus 3, and 2x plus 3. Notice here in the second line, it is only going to cancel in the middle term. Now, I'm going to go ahead and begin just because I can easily distribute this x to both terms here. What is x times 2x? What is x times 3? Well, that's going to be 2x squared plus 3x. I'm going to put a parenthesis around it, plus 4x plus 6 times x plus 2 all over x plus 1. Keep it large. And oh, all of these survive. And to be consistent, I'll keep this guy green. Okay. What I need to do now is multiply by another denominator. Notice how I'm slowly chipping away. It is getting a little complex in the numerators because of all the leftovers. But the key part is that each time I do this, my denominators are disappearing. I multiply by a factor of x plus 1, a factor of x plus 1, a factor of x plus 1. Notice that is the only part that cancels. Rewriting it out, I will multiply this later. X plus 1 times 2x squared plus 3x plus 4x plus 6 times x plus 2 equals x minus 1 times 2x plus 3 times x minus 1 all over 2. I need to multiply all parts by 2. I'm going to multiply this left part by 2, this middle term by 2, and this by 2, and that it will cancel. And then this is where I'm going to begin to start simplifying. I'm going to distribute this 2. This is going to be 2x plus 2 times 2x squared plus 3x. I'm going to distribute the 2 here, plus 8x plus 12 times x plus 2. And then I'm going to clean up this side. X minus 1 times 2x plus 3 times x minus 1. Okay. No denominators. Yes, this is a little complex. Nothing I can't handle. I'm going to multiply this first bit using an area model. So let me just draw it underneath it so I don't get myself too confused, because there's going to be a lot of these going on. I have 2x and positive 2. I have 2x squared and 3x. And I multiply these guys together. What does this first part mean? Well, this simplifies to be 4x to the third plus 10x squared plus 6x. I combine the 4x squared and the 6x squared. Next on my agenda, I am going to multiply these two binomials together. 8x and 12 times x and 2. This is going to result in 8x squared, 12x, 16x, and 24. I'm going to combine the middle terms to get 28x plus 24. And to avoid frustration, I am going to multiply these two separately. I'm going to do this bit first. X minus 1 times x minus 1. X minus 1, x minus 1. X times x is going to be x squared, negative 1x, negative 1x. And then this is going to be positive 1. So this is all going to be equal to x squared minus 2x plus 1 times 2x plus 3. So I am going to have to do one more area model on the right, but I'm going to begin to simplify the left. I'm going to go from descending order. I see 4x to the third is the greatest power. I then am going to look for 10x squared. 8x squared is going to make 18x squared. I'm going to see 6x and 28x make 34x, and then add 24. And then I need to multiply on the right. I'm going to draw an area model, and notice how it is x squared minus 2x plus 1. So I need to have a larger to include all the terms. Notice how it's a 3 by 2. What am I multiplying by? 2x and 3. This is going to result in 2x to the third minus 4x and 2x, 3x squared minus 6x plus 3. And I'm going to combine terms in the same way I did up above. 2x to the third is the same. I see, this is supposed to be x squared. Minus 4x squared and 3x squared is going to make a negative 1x squared. Next up, I'm going to see negative 6x and 2x. It's going to make negative 4x. And then finally, I have 3. And I finally have been able to clean it up in such a way that, hey, I do not have any multiplication. I have a polynomial. Yes, it's long. Yes, it's complicated. And now I'm going to the final part of my process is I'm going to have to use the zero product property. I need it to be equal to 0. So I'm going to minus 2x to the third on both sides. I'm going to add 1x squared to both sides. I'm going to add 4x to both sides. I'm going to minus 3 to both sides. This is going to create 2x to the third plus 19x squared plus 38x plus 21, which is going to be equal to 0. Now let's just remind ourselves of our restrictions before we go too far, because this has been a lot of work. X cannot be negative 2, x cannot be negative 1, and x cannot be negative 3 halves. X cannot be negative 2, x cannot be negative 3 halves, and I believe x cannot be 1. Negative 1. Good thing I checked. So far, we essentially took this equation, we got rid of all the denominators, we combined like terms, and now the process would go to be factoring it. You would have to look at it. Do you have an opportunity to factor by groups? Do you have to factor by synthetic division? And what you're going to reveal is that by using Desmos, you can identify all of the x values. So what you're going to do is you're going to take this bad boy right here, and you are going to look for the values that is equal to 0. You're going to look for the x-intercepts, which are all of the values. It's going to be x comma 0 because they're x-intercepts. So you should have 3 solutions. You're going to have x equals something, x equals something, and x equals something. And then you're going to have the restrictions where x cannot be negative 2, x cannot be negative 3 halves, and x cannot be negative 1. This is a complex problem, not impossible. So go ahead, use technology to graph this, and you should be able to find the 3 solutions. I hope this helped. This is it for now. Ciao.